Hope you are doing well. Today we are going to discuss the topic diffraction. Diffraction is basically the bending of waves around the corner or the edges. Bending of a wave around corner or edges when passing through a narrow gap. So these are actually the vertical lines are actually called the wavefronts. Wavefront is basically an imaginary line which join all the adjacent points on the top of a wave. So, for example, if I just want to tell you like how these wave fronts actually being formed. So this is actually the top view of all the waves which are collected, and I have made an imaginary line drawn with the red color. So this basically wavefront is depicting all the points at the top of the wave. When these wave particles are at the top, when I just joined them, they were all in phase with each other, like they were rising and they were falling. All the particles falling were at the same time, so they would be named as like these particles are in phase. So because the distance between the two crests, this point is called crest, the top point of a wave is called crest. So the crests on the top, when these two waves on the when the waves are displayed on the screen, so we should know like the distance between the two crests is called the wavelength. So I have to see now how the wavelength is concerned with the gap. So over here, in the first situation, in the case number one, the gap size through which the wave has to pass is very big as compared to wavelength. But in the next case, the gap size is actually big through the when passing through the wavelength, like when wavelengths are being passing through this gap, so the gap size is actually bigger than the wavelength. So how do we remember these things? We should remember like whenever this is the situation, we have to draw at least three wavefronts. These wavefronts must be equispaced in order to show like the speed of these waves haven't changed overall. So these are the wavefronts. They must look like almost equispaced. So you should draw three wavefronts and they must be curved as well. Now over here, this is the situation when the gap size is very big as compared to wavelength. In the case number two, the gap size is bigger than the wavelength, so there would be a bit more bending. In the first case there was a least bending, so in the first case it is least bending. In the case number two, it's a bit more bending. And what would be the properties? Like speed would remain same after diffraction, wavelength would remain same, and frequency, by the way, never changes because it depends upon the source producing the wave. Similarly, the speed and wavelength would remain same and frequency would also remain same. We know the formula V equals F lambda. So V is directly proportional to lambda, which is the wavelength. So if wavelength increases, the speed increases as well. If wavelength decreases, the speed decreases, but the frequency should be kept constant. So these are the two cases so far. And what if the gap is equal to the wavelength? So in this situation, if the gap is equal to the wavelength, then there would be maximum bending and we would be having the circular wavefronts this way. So these are the three cases of the diffraction. The overall speed would remain same, wavelength would remain same, and frequency would remain same. Why the frequency remains same? Because it depends upon source producing the wave. Depends upon the source producing the waves. That's all for today. Take care. Thank you.